Streaming त भइरहेछ तिम्रो यो फेसबुकमा स्ट्रिम हो लाइभ भइसक्यो
Okay.
Okay.
Yeah.
Start.
Okay, sir. So shall I begin the program, sir?
Please go ahead, sir.
Yeah. Okay. So welcome and good afternoon, everyone. Yeah. Everything is all right. Okay. So welcome and good afternoon, everyone. It's an honor itself to honor this beautiful audience who are here for our session 2 of webinar series on need of energy efficient building. Today, we're gonna have our talk on approach towards sustainability, design and practice of energy efficient building in Nepal. Before beginning, I would like to provide a limelight to a master degree in energy efficient building in KU. It was established in 2018 with an aim to train our candidates to enhance their knowledge in energy efficient building design from a multidisciplinary approach. On this program, I, on behalf of graduate student in EEBD, the organizer of this event, would like to welcome and extend my warm wishes to our all attendees, and I would like to express my gratitude to the speakers who are here to share the knowledge and expertise towards design and practice of energy efficient building in Nepal, paving the way to sustainability. My name is Chitis Pandit. I am enrolled in master degree in energy efficient building design in KU in 2018. I highly valued this opportunity to moderate this event. About the details you are posted with, our speaker will have 25 to 30 minutes to discuss. We'll have 3 speakers for our presentation session, followed by 15-minute question answer session at the end. Meanwhile, you can post your queries into the chat box, and for further discussion, you can raise your hand in the question answer session. We'll try to cover up all the questions addressed. This session is made live through our event page on the Facebook, and entire session will be recorded for the further needs. Now, without any delay, I'd like to welcome Dr. Bhim Prasad Shrestha to set up the stage with his opening and welcome remarks. Sir, the floor is yours.
Thank you, Chitis, and we really appreciate for making this thing happen and putting all the technologies, knowledge, brain, personality together at the same platform. And particularly today, I'm very much delighted. Today is the second day of our webinar, webinar number 2 that we are organizing on energy efficient building design in Nepal. Especially in our first session, and we had a speaker from Kathmandu University, Prof.Rabindra N, followed, and he had his researchers, Sushil Chaulagai, made a very good presentation. And it was followed by a little bit of experience speaking from the renowned architect, Mr. Kishore Thapa. He has a long experience of working with the government sector and working in this particular areas of urban settings and urban design. So Kishore Thapa highlighted the issues regarding some of the challenges that need to be dealt with the government side. And finally, we had, in the first session, we had a speaker from the DUDBC, that is a Mr. Sachindra Dev, who is currently working as a senior divisional engineer at DUDBC in Nepal government, and he was trying to see the mitigate some of the pros and cons and how the problems with the energy efficient building design could be tackled. So these were some of the highlights that we work on the first session of this webinar, especially talking about the more on the policy side, more on the implementation side of the government bureaucrats and others. And as in continuations, today we have veteran speakers, mostly from academia. And today we have a speaker like a Prof.Dr. Sushil Bajracharya, and who has a long experience at the Institute of Engineering, starting architecture program and trying to educate hundreds and thousands of people who could be the future flag bearers of this energy efficient building, this campaign in days to come. So similarly, we have Prof.Rabindra N, Bhattarai, who has a long experience. I had a very good chance of talking with the Professor Bhattarai. He is trying to develop a green housing system, green buildings, where the green building could be designed with the energy, self-energy sufficient. The energy need not be taken from outside. So that kind of initiative being taken by Rabindra Bhattarai and Mr. Ar.Ujjwal Man Shakya, and probably we came to know he is the only person at this moment who thinks the building from energy perspective. So today we try to bring some of the stalwart in academia who has a pioneer or who has championed in advocating the energy efficient building design needs and its applications since. So today is mostly we'll be trying to see about how we can knock out some of the barriers in a design and practice of energy efficient building, mostly in a conventional way, or mostly in academia, or in a practice. Probably Professor Sushil, who has the pioneer in starting this architecture program and embedding this energy efficiency and energy related issues in a design aspect. And Ujjwal Man, on the other hand, has been practicing this theory into reality. So basically today we'll be talking. The stalwart speakers will be giving their views, their experience, and we have a student, mostly the students of the energy efficient building design at Kathmandu University. At the beginning, this program, we began with the support from the European Union. In fact, today is Erasmus Day, and October 15. I'm also running one of the projects with Erasmus, and I told them that we are working with several institutions, and the method. I mean, one of the philosophy of having collaborative European university is try to not only to go there and to bring their knowledge back to Nepal and how we can work together. Especially talking about the energy efficient building, there has been several practices and several theories developed in Europe, and they have practiced it too. So how we can blend and taking this Erasmus Day as a October 15, 16, 17, these 3 days are considered as Erasmus Day, and we hope that the partnership between European universities. Tomorrow we'll have a speaker from Austria, and who has a long experience of working in this sector. So without much taking time, I would like to request Prof.Dr. Sushil Bajracharya, who is also Assistant Dean and very good friend of mine. We had a lot of conversation, discussion regarding several collaborations between Kathmandu University and IOE in the Punjab. So let's welcome Dr. Sushil Bajracharya at Institute of Engineering to highlight on practice and design of the energy efficient building. Dr. Bajracharya, sir.
Okay, thank you, BMG.
Yeah.
Can you hear me?
Yes, sir. We can very well hear you. So you are also on live, and people are watching. Several people are watching. We are very glad to see you there.
Thank you very much, dear Professor BMG, dear Professor Daniel from the Kathmandu University, and dear Professor Rabindra Bhattarai from Institute of Engineering, and dear fellow architect Ujjwal Shakya sir, and dear students. First of all, I thank you, Mr. Chitis, and thank you for the students and faculties of Kathmandu University, especially Energy Efficient Building Master's Program. And dear viewers, today my topic is related to my profession, academic profession and architecture profession, that is design and practice of energy efficiency in buildings of Nepal. Can you see my slide?
Yes, sir.
Yes, okay. Thank you, thank you. This is the content of my topic today. I will talk a little bit about the historical background of energy efficient building in Nepal and present building practice and the initiatives for energy efficiency in building by private sector, academic sector, government, municipality, INGO like UN Habitat and Society of Nepalese Architects like our society, and the way forward for the need of energy efficient building in Nepal. As we all know in our historical background, our traditional buildings, especially from Kathmandu Valley, have long history from our past Lisavi and Malla dynasty period from 9th, 10th century. And these buildings you see here in slides, we are using, our people are still living in this residential building, and still people feel very better thermal comfort and energy efficient and environment friendly. And that is the warm in winter and cool in summer compared to this modern residential building. So I did first my PhD research in the thermal performance of these traditional residential buildings of Kathmandu Valley. What I found, I did the lab experiment, and I put thermometers in the traditional residential building as well as in modern residential building in Kathmandu Valley. I found that the traditional buildings is minimum 1 to 2 degrees Celsius comfortable in summer as well as in winter compared to the so-called modern buildings. And what does it mean, 1 to 2 degrees Celsius comfortable in summer and winter? Means it is warmer, 1 to 2 degrees Celsius in the winter and 1 to 2 degrees Celsius cooler in summer compared to the modern buildings. So the 1 degree is like 10% energy efficiency in our context. In as experts, many scientists have proved that 1 degree Celsius is, if we energy efficient, means 10% energy efficiency. So our traditional buildings are minimum 10 to 20% energy efficient than modern residential building. So this the temperature, the comfortable temperature 1 to 2 degrees is already proved from my research. And many, not only in Kathmandu Valley, in all our 3 climatic regions, in the Bhattarai, in the hilly, and in the mountain, we have very much good vernacular buildings which are much more thermally comfortable, energy efficient, and suitable for local climates. There are many research and the topics people also feel that is, but nowadays we see that the architecture development from past to present scenario, we say that like our all the vernacular, traditional, and historical buildings are green buildings. As now green building has special principle. If we compare all the buildings are green. Then in modern architecture, we went towards the gray architecture, which cannot is not very good for the energy context, not care environment, not so much comfortable if we compare to our traditional residential buildings. So this is not my slide. In our urban planning also, we see our urban buildings, urban growth is haphazard. We don't have special zones like for the apartments. So there are much more problem to the surrounding and the neighborhood, those who reside near the apartment. So this is the problem. So we say sometimes where we are going, we are not going towards the green, we are going gray. But nowadays, I did many researches, and my students also did many researches, and we found that the design and form, material, technology is changing from traditional to modern. So what happened from design, form, natural to artificial material, we change when we develop our architecture practice in building, residential building and other buildings. We compromise the comfort, we compromise the energy efficiency, and we compromise the environment. That is the problem. If we did not compromise the comfort, energy efficient, and environment in our modern practice, so we should design the modern building with energy efficiency, with green principle, with sustainable principle. But we are forgetting about the comfort, energy efficiency, and environment. That is the problem. We see these problems in our environment, in our urban areas in Nepal, different problems like environment pollution in Kathmandu and other cities of Nepal, energy scarcity problem, water scarcity problem, scarcity of building material, and waste management problem. We all feel in our urban context. We see these pictures in our context. We had a very long load shedding problem a few years back. And nowadays we can see in my picture, in Kathmandu also we have the air conditioning shops, because the temperature raised in Kathmandu Valley if compared with 10 years back. So the global warming also affecting in our local context. Nowadays, I see that our building practice recent develop is from traditional to conventional. Now from conventional to a few people, few architects, a few energy experts wanted to go towards the green or energy efficient, eco-friendly or sustainable buildings. I compare here many of our nearly 50% population is still living in traditional building. And then we are building many conventional type buildings. Now people are aware about the comfort, aware about the energy efficiency, aware about the environment. That is why we can see nowadays green, eco-friendly, energy efficient building in our surroundings in different parts of the Nepal. So these are a few examples. There are Matoghar, there are zero energy building, there are the different building with different design, form, material, technology, considering the environment, considering energy efficiency, considering the comfort. Is that? So for the towards to develop in our context energy efficient design or green building or sustainable building in Nepal, I see many initiatives from the private sector, academic sector, government sector, municipal sector, NGO, UN Habitat, and our professors construct Nepal, but a very few number. In academic sector, if you see Kathmandu University, there are many master's researches, PhD researches in master's and PhD programs. I know that this program is organized by the MS Masters of Science in Energy Efficient Design program. In our Institute of Engineering, we have also MSE EED program, Energy Efficient Design program in Architecture Department. And we can see little initiatives from our Nepal government. They already start making little policy and guidelines, still in draft mode and other. And also a few municipalities like Dharan municipality operated bylaws for the energy efficient building, for the green building. I will show later on. And INGO like UN Habitat Nepal did few researches, few trainings and awareness program in Nepal. So, like the environment ecologically responsible architecture guidelines. So we can see here, private sector, academic sector, government, municipality, INGO, SONA, they had initiated little initiatives towards energy efficient, green, sustainable building in Nepal, but it is not sufficient. So in we can see different kinds of types of building in our country, in our different part, with the traditional material technology in modern building and a traditional way building, And with the RAM or technology, with stone masonry, you can see in Bhattarai, Namunahar, also in the Patan, in Shota area, different Sreshta houses, different RAM or buildings, you can see from the private sector. Likewise, our architect Vibhuti Man Singh already designed and constructed few buildings under the building developed with the LEED rating system, which is American system leadership in energy and environment design, and focused to approach to give better comfort, better energy efficiency, better environment saving system in Nepal. And I knew among these three, two buildings were built, that is Siddhi Polyclinic in Charkhal and Hama Iron and Steel Building in Kamladi. I think Professor Rabindra N was engaged to design these buildings. He will tell you more about it. These buildings were green, passive design, and renewable, use many renewable energy techniques. This is the initiation from the private sector, from the architects, from the consultant, and also the Ujjwal sir will tell his design. He also always focus in his design about the green energy efficiency and passive design. So from the private sector, I also engage in this the Sagarmatha next project in Namche to develop sustainable building near the Namche, and I see architect Ujjwal Man Shakya also designed Butwal Power Company in New Baneswar in Kathmandu with the energy efficient incentive practices. He will tell it later on about. So these are the approaches I see here in Nepal about the building design with energy efficiency technology and sustainability from the private sector. Also, there are many these private sector NGOs which develop the affordable green and energy efficient building. I did many research with my students to take the different kinds of buildings. That is, we say affordable building, which is low cost, which uses passive and green technology using compressed stabilized earth block and earth bag, bamboo, mud by individuals, by architects, by engineer, by expert, by NGO, by INGO, etc. These are few examples which are you can see here from some buildings from Institute of Engineering, some buildings from the art bag, some buildings you develop in different parts of Nepal as an affordable building using the energy efficiency concept. This is also I collected from my students using the different bottles, rat trap technology, VSBK brick, Inco panel, prefab. This is the affordable different green materials and technology for the design of the green building, energy efficient building, and different technology in Nepal was adopted. In academic sector, I can say from as I am also now working as an assistant in Institute of Engineering, we have many master's programs which are related to energy. And now I'm also coordinator for the PhD program. Under my PhD program, there are 10 PhD researchers who are mainly focused in their research in energy sustainability study in building and other sector. As well as in Institute of Engineering, there are many master's programs like energy efficient building design and energy for sustainable social development and energy system planning and management, renewable energy technologies. This top two program is running in architecture department, whereas this MES-ESPM and MES-REE running under the mechanical department of Unchur campus. So we initiated many master's program related to energy. Actually now in IOE there are 32 master's program. Many 4, 5, 6, nearly 6 master's program related to energy. So in not only we did academic design program, we also initiated first zero energy building in Nepal under the Center for Energy Studies. This is the zero energy building in Nepal. That is, we started in 1999, and Professor Rabindra N Bhattarai also engaged as the expert in this building for the earth tunneling and other technology. So also we also built one building climate responsive model classroom in 2009 in architecture department of Ulcho campus in Institute of Engineering. This is CSED building, campus stabilized art building, which is very green, energy efficient. This is the model for the classroom for Nepalese government schools. This is model we developed in 2009. So this is in our academic sector also, we built model buildings for the development of energy efficient building in Nepal. And I see in our government also as little policy and guidelines they developed in 2069. That is Hari Bhavan Parvedi Nirdeshika 2069 draft. I didn't know about that. This draft was not completed and still in draft. And also the Sanghiya Mamila Tatha Sthani Vikas Mantralaya developed the Environment Friendly Local Government Framework in 2013. This is little initiatives for the energy efficiency in Nepal. And also I know that I also engaged in to build the Dharan Nagar Palika as the sustainable city, and we did training in Dharan, and Dharan Nagar Palika changed local government changed for as a first municipality to make the Harit Bhavan Awas Kulai Chani Pravdan. That is, they changed the few rule and regular bylaws to develop the green homes, energy home in Nepal. That is, they gave the 50% waive in building permit fee. They provided green channel to build building permit, and they increased the completion period by 1 year. They also supported to install the rainwater harvesting solar panel biogas for the resident of Dharan municipality, and the different bylaws were changed. You can see the Harit Bhavan and Antari Bayu Gunostar, they did many things in Nepal. First municipality to initiate in the this energy efficient building, green building. Also, I remember I was also involved in UN Habitat Nepal in Green Homes program, and they did the research, training, and awareness for the development of energy efficient building in Nepal. They targeted government, they targeted for the municipality, they target for the urban people, they target for the consumers, and also the professional researchers and public. So they targeted 3 cities in Nepal, especially Lalitpur, Pokhara, and Dharan. And we went there and we did the trainings for the people for the sustainable housing for designers of these municipalities a few years back. So in Green Home program, they prepare the guidelines to promotion of sustainable housing with the 5 components: green building materials, passive solar design, energy efficiency, water conservation, and waste management. So these are we develop the guidelines in green construction material, sustainable, what is sustainable building material, how the energy should be less by using less embodied energy, less carbon footprint, etc. So also how we can promote sustainable building or housing in Nepal with water conservation, with waste management, with rooftop farming, Kausi Kheti in Nepal, in different Also, UN Habitat Nepal under the Green Home Program, they did many researches. I was also our team, and we developed guidelines, energy auditing in contemporary residential building, different green building guidelines, etc., to develop the energy efficient building in Nepal. Also, our Society of Nepalese Architects had initiated they initiated one committee, that is ecological responsive architecture, to develop the ecological responsive architecture guidelines, that is ERAG for Nepal. Under the leadership of our senior architect, Vibhuti Man Singh, who was also past president of the SUNA. Still, this is under the development, and many workshops, many conferences were organized, and many architects involved, but still not complete. They are still working under it. So there are many initiatives. So what is the way forward for energy efficient building in Nepal? So there are many things still we should do. There we have talking many times from long ago how we can develop, how what should be done. We manage many trainings. So in my opinion, we should have special building code for energy efficiency in Nepal National Building Codes. We should focus, many Nepal National Building Codes focus on conventional building practices only. But we have only few or some green and energy efficient components as considered as low cost technologies. So we should have separate building code for energy efficiency in Nepal National Building Codes. And we have many challenges to develop the energy efficient building. We need it. Every people agree with that we need energy efficient building, but many challenges. That is, the first is not enough study and researches in Nepalese context. Many energy efficient building program also only study the literature. As I see our student also read the literature from the abroad, from the USA, European, but not in Nepalese context. So no enough studies and research in Nepalese context. And we have less awareness to policymakers, our government, our ministry, our department of DUDBC, and we have less awareness among the users. So we have to make more awareness to our policymaker and users. And we have lack of data about the energy efficiency in building with the material technology as well as different proper technology. And we have less human resources. I think if now IOE and KU has the master's program, and after a few years there will be many human resources in these fields. And we have less green initiatives in different projects of the NGOs, INGOs. Green initiatives not taken in our NGO and green INGO project. So, and our now IOE and KU started to focus on the green building technologies, but many universities still focus only on the conventional building technology. Now we are changing we are now guiding, now we are making awareness to our students to make expert in green building design. So we are going ahead, but still we have many other universities and technical colleges. They are still focused on only the conventional building technology. So we need policy and guidelines, need more specific policies and detailed guidelines related to sustainable energy efficiency in building sector. And we need provision for energy efficiency or eco-friendly housing in national building codes. I already explained. And we also need at municipal level, municipal planning and service delivery to promote energy efficient buildings. now only in the Dharan municipality they have adopted, but no, we have now 293 municipalities. There are only guidelines for the gray buildings. They are developing only gray buildings. So we have to change in our municipal level also. So final, I can say we need joint initiatives of government, municipality, our university and private sector. So I think from government, Department of Urban Development and Building Construction should finalize green building guideline, this draft, and develop policy for green building code and energy efficiency in buildings with the coordination with the academia and other stakeholders. I think our government sector do not coordinate with the universities like Kathmandu University and Institute of Engineering, Cuban University to develop these guidelines. So we are ready to give the advice, do research for them, but we didn't get the coordination and cooperation government side. We need and so our government should coordinate with the conduct necessary research in IOE or in Kathmandu University for the development of energy efficient building in Nepal. That is the main point I suggest here. So this is for me. I took only 3 minutes more. For me, I think within 25 minutes, I took 28 minutes. Thank you for once again for BMG and the Kathmandu University and student cities for giving me to say something about energy efficient building in Nepal. Thank you very much. Kshitij.
Thank you,
BMG.
sir. Yes, sir.
Thank you, sir. Thank you, sir. Kshitij, please go ahead.
Yeah, okay, sir. Thank you, Professor Sushil, sir, for your wonderful presentation. Okay, so, okay, so it was really a insight to pave the vision towards initiative taken by our institution, taken by our government, and of course taken by our municipality for initiating the green building design, where you have taken us to the transition from traditional building to conventional building, and of course the need of energy efficient building. Yes, there are many problems we are facing here, the lack of human resources, lack of technology, and of course the awareness between we peoples, and the lack of coordination between government sector, institution sector, and we academia. Well, without further delay, I'd like to uh, invite for our next presentation, we have Professor Rabindra N Bhattarai, uh, to provide an insight to challenges and opportunity to HVAC system designer. For knowing the Professor Rabindra N Bhattarai, he is a well-known figure in the Society of Mechanical Engineers in Nepal, and for the ASHRAE in India. He is an expert for HVAC system. With 40 years of experience in HVAC area, he has shown his several expertise in different applications like star hotels, hospital buildings, high-rise building, schools, and so on. Um, he has been as the director of the Center of the Pollution Studies of IOE TU. He was involved in developing the very first training course in refrigeration and air conditioning in the Institute of Engineering, one of the pioneer in the green building design and setting up the energy efficient building trend in Nepal. So now I'd like to invite Professor Rabindra sir to drop his remarks. Sir, the floor is yours.
Thank you, Kshitij. Thank you, Bim sir, and I welcome my colleagues, Ujjwal sir, Professor Sushil sir, and all present colleagues and students. Welcome to you, and thank you for this opportunity to share things with interested participants. Now, let me start by sharing my screen. Is it visible?
Yes, sir.
Okay. Let me start. Energy efficient buildings, challenge and opportunities to HVAC system designers. Now, it's a very great challenge and very great opportunity. I'd say it's both at the same time. My voice is clear, I hope. Is that right, Satish?
Yes, sir. Your voice is clear, sir.
Thank you. It's important because you see more than our 80% of time is spent in buildings, either in offices or private residences or what have you. And so we want to be comfortable in the house where we spend 80% of our time. So even from the prehistoric times, people burned fire and in cold climate to become comfortable. So this ongoing quest of human nature. So by the time we came here, different countries are spending different level of their expertise, their energies in keeping the house warm. So it varies. European Union countries spend more than 40% of the total energy for HVAC and for buildings, let's say. That includes some energy for cooking, where they use electricity. In other cases, not. Now, compared to that, look at Philippines. Philippines spends only 15 to 20% of the energy. And whereas Brazil spends 42, Florida and USA 46, and California 66. You see a trend here, very interesting. You know, it ties up with the people's buying power also. In Philippines, it's only 15 to 20%. And at the same time, weather is not as harsh as in California. But California, its buying power is high, so they can afford more energy for building. Yeah, while we talk about this energy, please don't confuse with Nepal energy scenario. But when we normally read the energy report of Nepal, we say that 80% of energy is used in domestic sector. That's a different form of energy we're talking about. This is high grade energy. It's fossil fuel or nuclear power. But when you say 80% of our energy is used in domestic sector, that's basically for cooking purposes. So please don't confuse with that energy. This is for keeping the house basically warm enough for people to live. And you know, as an academic person, the way we look at the system is, you know, there is a building gross energy needs. The energy need is fixed. That depends on the locality, building, type of building, building material, and what have you. That decides what gross energy requirement of a building is. And then there are natural energy gains, and there are internal heat gains. And by internal heat gains, I mean the heat gains from people living in the buildings. And if you add this natural energy gains and internal heat gains, then what remains from the gross energy need is the building net energy use. This is a building net energy use. Okay. And out of this net energy use, what we try to do is renewable energy. We try to make renewable energy input into the total energy building use. And that mine assistant there, and that basically is the building net energy use minus renewable energy use we supply into the building is the delivered energy. But then delivered energy is actually a little higher than this because of the system losses. And then in some rare cases, there would be some energy would be exported to some other use. In Nepal, this exported energy is equal to zero, and system loss, renewable energy. What I'll come later on, what we're trying to do is, this is the general scenario of how we need to look at it, because the moment we see green energy or energy efficient building, we can try many things and many building materials, but at the end of the day, we have to prove to people that how much energy we save by alternative measures. People are going to ask that question. We cannot just let go with saying that I use this thing, and so energy in my building is energy efficient. We have to prove with hard data. So we need to account for it. Now, I'll talk basically for some issues to understand how complex this thing is. Energy gain or loss. Energy is gain if it's a heating time. Energy building gains energy from the surrounding. And if it's a winter, if the outside temperature is 30 degrees, let's say 2 degrees, and we're trying to maintain the house at 24 degrees, 22 degrees, then it's energy loss because our building is losing the energy. So in summer, it's gain, or in winter, it's loss. That's a function of delta T, difference of temperature between inside and outside. So, if we want to make delta T higher, that means we're increasing the energy loss, talking about the winter. If we say outside ambient temperature is 2 degrees Celsius and we want to maintain at 20 degrees, then our delta T is 18, right? If we maintain it 22, then delta T is 20. If we want to maintain at 24, then delta T is 22. So then it will have a direct impact on the electricity we want to consume. So the question is, how much delta T is good for us? How much delta T? That will gain by the human comfort chart. If you look at the psychometric chart, there is a range of temperature and humidity which gives human comfort value. So we need to be as close to it as possible. And then there are clothing insulation CL, that's normally we call it CLO values. And human tendency also. By human tendency, if we are people living in cold climate, they want to be on a little cooler temperature than those people who live in high temperature. Let's say India, Nepal. So this personal tendency, and then there is small children need more warmer temperature than adults. Then that's a function of U walls. Now again, U is a function of thermal conductivity and wind velocity outside. So basically, let's say if we're adding insulation, then it's a question of insulation, or without insulation. That's another factor which is constantly changing our energy gain or loss. Then direct solar gain. Direct solar, there are two components of solar gain. One is the conduction component that conducts through a glass, and that is governed by the normal conduction equations. And then there are radiation heat gain. Radiation heat gain, the media doesn't matter, so it comes directly. Direct solar gain basically refers to the radiation gain through the glazing surfaces. If it's depending on the time of the day, inclination, orientation, the direct solar gain and conduction gain may vary. And then there is a question of infiltration. Now, KU team led by Professor Vivek had done we saw yesterday that report on infiltration. The building, if you look at the American standard, the buildings are quite tight. But from Nepalese standard, buildings are, the doors and windows do not fit properly, and we have lots of infiltration losses. Now it's a question of, I say losses because with a pinch of salt. That's a losses or gain we have to decide. We'll come a little later onto it. And then door openings. This is a very big factor when we say building designs and you are running an air conditioner, 2-ton air conditioner in a room, and you keep the door and the room outside, the space outside is not air conditioned, then there's no point in talking about energy efficient building. You are trying to cool the building and let the warm air come inside. That's a lot of social and other aspect of how to maintain the room besides the machines. The door openings in our case, now I know most of us have been to that hotel for parties and big functions. There's a big banquet hall and then the food is served outside. and the banquet hall is air conditioned. The food is served outside, that's in the open, shaded area, but not air conditioned. And the whole doors are flung open. And I know I'm personally involved in that banquet. 2 times they have augmented the capacity, cooling capacity in that room. But if you keep the door open, it's about I don't want to name the hotel, you might have guessed that. If you keep the doors open and go on increasing the capacity of the air conditioning system, it just doesn't work. So it's a big factor in countries like Nepal and India. And then U is a function of material, thickness, thermal insulation, and so on. And direct solar gain is, the area of glazing, type of glazing, filling orientation. Now, it's in India and even in Nepal, we've come across situations when building faces has lots of glazing area facing south, and then we're asked to make a very energy efficient design. Well, if that's what the client wants, you have to do it. But perhaps if the architect could convince the client of doing something to reduce that glazing or cover it with some shading, things would make a difference. And infiltration, it depends on the wind. If you are living on the 11th floor, you'll have one kind of infiltration. If you're looking in the ground floor, you'll have one kind of infiltration for the same set of glasses and doors. Or depending on the wind flow, you could have exfiltration, especially in the top floors, and door window types and door windows openings. I've talked about it. Let me go to next slide. Again, talking about the basic issue, this is let's say, hypothetical building. Now we want some energy stored in the building. Why? Because of our comfort. Now I, as a person, want to live in temperature between 22 and 24 degrees Celsius. That will give me an relative humidity of 40 to 60%. That will give me a human comfort. So that energy has to be stored inside my building. Now that is equal to energy gained from occupants. Normally, for normal residential purposes, energy gained from occupants, we ignore it because it's very less. Unless if you're talking about a gym where people are dancing and doing exercise. Normal sitting, not much energy occupant. Then plus or minus energy input from the machine. This is where your air conditioning machine is coming. It's either, if it's a summer, you're running a heat pump, you're adding the energy. If it's in winter, you're adding the energy, and in summer, you are subtracting the energy, you're sending the energy out. So it's a plus or minus. Then energy from outside, again, plus or minus, depending on the ambient temperature and the temperature inside the room, minus energy lost. Now, a house should be required to be maintained within the range of comfort temperatures, and it requires energy for illumination, food preparation, and so on. Okay. Now, air conditioning machines are used to maintain the space temperature constant within the human comfort zone. We need that. We need air conditioning machines because now even in Kathmandu, the temperature have gone up and buildings have been tighter. So we need machine to keep maintain the comfort. So energy use is again function of machine rating and operation time. Now you can select a machine perfectly for a room, say 3-ton machine. When you design a machine, we design with an assumption that machine room will not be open. Then in that case, maybe the machine would run for 2 hours and then it will be switched off by this thermostat. Okay. So in case of, let's say, in 10 hours time, if you run the machine for 10 hours and if it is switched off 40 to 4 hours, because your temperature is maintained, then the running time is only 6 hours. But if you flung open the windows and doors, then operation time is 10 hours. So for the same machine, you're using different kind of energy. That's what we need to understand. You cannot just plug in the right machine and expect good energy economy. It depends on the machine rating. If it's a machine is rated below your requirement, then it will keep running. It will never stop. Okay? So if it's properly sized machine, it should be allowed to stop by its own thermostat so that it can reduce the operation time and energy loss from space. Larger the energy loss, the longer the operation time, and longer the operation time, the higher the energy yield. So these are known things, but I'm repeating it for the sake of completion. Now, energy efficiency of AC machine, energy efficiency of building, green building. There are three things, three different things we need to understand. Energy efficiency of air conditioning machine is separate entity. Energy efficiency of a building is separate entity. Green building is a separate. These three are not same. Energy efficient machines refer to the coefficient of performance or energy efficient recovery ER of the AC machine. By COP, we mean, the air conditioning machine operates as a heat pump. Now, if you supply 1 kilowatt of power to the machine compressor and get 4 kilowatt equivalent of heat, then the COP is 4. Modern machines have the COP range of 3.5 to 4 VRV machines. That means if we operate a 1 kilowatt heater, resistance heater, then we'll get at the most 0.8 kilowatt heat output. But if you want a 1 kilowatt AC machine, we'll get at least 3.5 kilowatt heat output. That is the energy efficiency of efficient machines. That's just pertaining to machine. That has nothing to do with the building. And that machine will operate at that rate, irrespective of where you put it. If you put it outside, it will run more. If you put it inside, it will fill the room. But energy efficiency doesn't change. Then let's come to energy efficiency of a building. That refers to the extent to which the energy consumption per square meter of the floor area of the building measures up to established energy consumption benchmark for that particular type of building under defined climatic conditions. That's an international definition. There are definitions, many definitions, but this is one of the most used definitions. In effect, what I'm saying is, if I have my traditional building, which traditionally using traditional windows, traditional pattern of construction, traditional glazing, traditional sizes, traditional building materials, consumes certain amount of energy. But now I want to make it energy efficient building. I change the insulation, I change the orientation of the building, I change the glazing sizes, I make the windows and doors tighter, and my energy consumption of that building reduces by 50% per square meter, then my energy, if my building is 50% more efficient based on the benchmark of it. In Nepal, I have not come across a benchmark. I'll come a little later when Bhuti sir and we tried to do the lead building for Hama building and City Polyclinic. We had a hard time trying to convince the USDBA what our benchmark is for our traditional building. We had a hard time because we don't have established benchmark to which they can judge how efficient our buildings are. Okay. Now, green building is still different thing. Green building refers to the extent to which the energy consumption and other parameters such as local and transportation, sustainable sites, water efficiency, energy and atmosphere, material and resources, indoor environment quality, innovation and design, regional priorities, all taken together. So we're looking at three different kinds of efficiency. One, efficiency of the machine. Second, energy efficiency of building per se, without any mention to green building. Third, we're talking about the green building, in which we look at issues more than energy efficiency of the building, as I'll talk a little later. Now, having said that, let's talk about the green building certification scheme. One of the most widely used followed certification scheme is that of US Green Building Council, USDBC, and they call it LEED, refers to Leadership in Energy and Environmental Design. And the certification scheme is, they are very transparent. They give marks based on your design criteria, based on your best values. And they're so straightforward that if you're not satisfied with the marks you get, you have to submit the design to USGBC through email, submit in every step, and they award you marks. If you're not satisfied, you can appeal. So ask them to review it. Of course, they charge US dollar for reviewing, and it's not very cheap. So they give, if your building gets 40 credit points, then that building is certified. That's out of 110 total marks. If you get 50 credit points, that building is silver certified. 60 credit points is gold certified, and 80 plus points, 80 and 80 onwards are platinum certified. Okay. We tried lead building, as Sir said. We did architects like Ujjwal sir and Bibhuti sir were bold enough to try these energy efficient systems, and Bibhuti ji said, we'll try lead. Fine. But lead expert, and we used to meet every week for 2 hours in his office. We deliberated every point, so we talked to them how to go about it. And then we try to earn, and it's very clear how much the points you can earn. I'll show you later. And unfortunately, none of the 2 buildings got even certified. And there are reasons. There are regions which are beyond our control. There are regions which were in our control and perhaps we couldn't do it. I'll come to it on next slide. So these are the marks. Integrative processes, you get total credit is 1. Location and transportation, you get 16 credits. Sustainable site, 10 credits. Water efficiency, 11. And say energy and atmosphere, they couple energy and atmosphere, they did 33 out of 110. So it's not only energy efficiency. Green building is not only energy efficiency. There's a lot more things involved in it. It depends on what material resources we're using, what indoor quality. Look, we had 16 out of 110 marks for indoor air quality, and the 6 in innovation of design, and the 4 in regional priority. See, one of the things, they're very interesting. We learn many things while doing this 2 buildings. One building perhaps could be certified, but the owner got impatient, and he said he wanted to start the building. So he said, at one point, he said, forget the lead, I want to start the building, I want to move on. So he started ordering whatever AC he had to, because he had to complete the building. He just abandoned it. So that's it. So Hama building, we tried our best. The client was not in worry. He didn't pressurize us. We did, but very interesting thing happened. You see, there is location and transportation. There is one clause in USGBC that if a building is within, I forgot, within some miles of public transport station, bus station, okay, you get so many points. So from Hama point, okay, the nearest public transport bus station was in Putli Sadak. So we told them that there is a public transport bus, and this what kind of public transport bus type is a said microbus. Now, all honesty. And Pat comes the reply that microbus is not a public transport bus. See, American guy sitting in Seattle or Chicago can never for his life understand that microbus is a public transport bus. This is a traditional differences. So we didn't give point. So there was, but and in energy and atmosphere, they asked us on which line of DOE, Department of Energy software, simulation software, were there any flags? Now, we know and everybody knows that to calculate 2 into 2 is equal to 4, you don't need DOE software. What DOE software can do, the Excel can do. Elevated takes more time. So but they would understand only DOE software. That's their problem or our problem as we look at it. Now at one point, I talked to Bhiviti, why don't we buy this DOE software? And he said, let's try to find out how much it costs. And it costs a lot of money, So we said, no, we'll submit the figure, but we will not submit the DOE simulations, waveline, and where it was flagged, etc., etc., etc. And they didn't understand, so that was why we didn't get certified. There were some of the reasons. So in India, there are problems with lead because the Hamla G problem for 11 problem. I talked with many Indians and HBC colleagues. They say, Bhattarai lead very complicated. We don't want to go into it. But having said that, they have gone into it. Some of them have gone elsewhere. And then they have this two other ratings. Some of them follow a lead, some of them follow the IGBC, and some of them Grigor. Anyone can follow anyone. Now, this is the example of lead platinum billing. They have platinum 4 or 5, perhaps 6, something less than 10 platinum buildings. You know, they have earned a lot. So this is a ITC Green Sector 32 Gurgaon, the first corporate house in India to bag LEED Platinum. This is a very prestigious project. Made up of bricks and concrete comprising of fly ash, equipped with high efficiency equipment that reduces 53% of energy consumption over a conventional building. See, this is how we have to come up with the figure to boldly say to the world that this is energy efficient building. Unless we can give them 53% or 49% or some concretized numbers, people outside of Nepal are not going to take us seriously. We have to talk. If we want to go to the international forum and prove that our buildings are energy efficient, we have to talk in terms of numbers. And over a conventional benchmark, 40% of potable water requirement, zero water discharge, solar thermal, stormwater management, reflective high albedo, etc., etc. So there are platinum buildings in India. I think Rajiv Gandhi Airport in Hyderabad is either a platinum building, airport terminal, or at least gold building, platinum, gold lead. Now, Nepalese practice is very different. As Sushil sir said, and I'm sure Ujjwal sir would say, our requirements are different. We have an intermittent use of AC, where very few buildings, if there are any, except perhaps the 5-star hotels, where AC is run 24 hours a day. We run AC intermittently, 3 hours, 4 hours, 5 hours, 1 hour. Let me one AC chalana. That is our typical use pattern. And our use is Yoda Kota AC uncha charitira AC hundaina, surrounded by non-AC. And then if you are a corridor, 2 rooms here are AC, and then 3 rooms non-AC, 4 rooms AC. So that's how it's planned. And we have high infiltration roads from windows and doors, expensive control equipment. Control equipments are very expensive, so we don't want to go into very much control equipment. We have had problems with control equipment. In one of our projects, we did with Ujjwal sir, lack of trained manpower for handling and weather issues. Now the problem is, we talked about the tight building. Can we tell our client to make it tighter windows and doors? If you look at this weather data, this is weather data by ISHRI. Those of us who attended the ISHRI meeting last meeting at Hotel Yakaneti must be having that copy with them. Even in May, June, and July, this is 75 percentile of daily temperature, driver temperature, is around 25. In April, high temperature 30. In May, highest temperature goes to 32, but for how many hours of a day? If my client says, Bhattarai, my 75 percentile temperature is 25, so I'm happy with windows, which leak a little bit, but it's a lot cheaper. How do I convince him to go for tighter windows? So these are our social issues. Our temperature is such that, like in Canada, you cannot have a leaking window. When I was in Canada, we used to be minus 40 degrees outside. हामीले खसी किनेर ल्याएर बनाउन राख्दियौँ, आइसले पुर्यो 3 महिनापछि झिकेर खाँदा फ्रिजमा राख्यो भन्दा चिसो टेम्परेचर -4. त्यहाँ we cannot afford to have any leaking window. But Kathmandu, why not? टाइट विन्डो बनाउनलाई 8 लाखहरु खर्च हुन्छ भने मलाई के फरक पर्छ? It's already comfortable temperature. Pure logic like कसरी काट्ने? So this is the social issue. And relative humidity is also comfortable. I'm almost close to my lake. And हामीले बुझ्न पर्ने चीज के भने हामी गभर्नमेन्टलाई कोड बना भन्छौं. हामीले नै गलत इन्फर्मेसन दिइरा हौं कि जस्तो लाग्छ कहिले कहिले. कोड बनाउनु पर्छ तर के कोड बनाउने? See, lead is voluntary. In US, nobody asks you to say that you have to go lead for lead. In Griha was started in the year 2007 on a voluntary basis, and it was made mandatory for not people like you and me, for state government implementation 2017. Stay voluntary बाट state government ले चाहिँ गर्नै पर्छ है भन्नलाई उनीहरुले 10 वर्ष लगाए. That's how it evolved. हामी चाहिँ के भन्न चाहन्छौं भने हामीले गभर्नमेन्टले कोड बनाइदियो भने त सबै प्रब्लम will be solved. It will not be solved that way. गभर्नमेन्टले कोड बनाएर सल्भ बनाउनु भए त भोलि गभर्नमेन्टले कोड बनाइदियो त no Nepali should have COVID-19 भनेर. Nobody would have COVID-19. Code doesn't solve the problem. Code only helps when there are enough material to streamline it. Now, I'm almost close to my end. Sorry for taking a few minutes more. अब हाम्रो current trend चाहिँ के छ त? एकै बिल्डिङलाई मैले अलिकति उकेरेको छु. हामीले लिडमा पनि के गरेका छौं अनि उज्जवल सर हामी के गर्छौं भन्ने नेपालमा हामीले चाहिँ at least Ujjwal sarसँग Beauty sarसँग मैले चाहिँ except for that lead, we try energy efficient building. Having said that, benchmark सोध्नु होला. Benchmark त मैले दिन सक्दिनँ किन हाम्रो standard benchmark छैन. मैले भने benchmark त मेरो calculation हो. You might believe it, not believe it. Governmentले benchmark बनाएको छैन. Okay, so what we try to do is we try to minimize the energy loss. Natural gain जे हुन्छ त्यसमा धेरै चल्ने ठाउँ छैन. बिकज तपाईले यो गेन बढाउन झ्याल बढाउन भयो भने गर्मीमा फेरि हिट लस बढी गेन बढी हुन्छ. So मैले देखाएको छु, suppose this in a gross energy need is 100 and natural gain is 5, internal gain is 1. So that means net grid energy requirement is 94 units of energy. You 94, if I can pump in 10 units of renewable energy, this is what Ujjwalji and I am doing in our projects. We're trying to pump in more energy through renewable means. Then I use better total electricity consumption घटाउँछु म. 84, 94 minus 10 is equal to 84. तपाईँको system loss 10% लिनुहोस्. 84 भनेपछि instead of 94, मैले 92.4 भइपुग्यो नि. That's why I'm claiming my energy is energy efficient. That's how we claim. And that is technically right. हामीले benchmarkबाट बताउन नसके पनि. अनि हामी के गर्छौं अर्को we try to do the temperature control by efficient VRV machine in swing. In air conditioning म त्यो डिटेलमा अहिले जान चाहन्न. Temperature swing बढी भयो भने we lose more energy. We try to maintain the swing to minimum. Then we try to use free cooling to reduce annual energy. In Hama building मा try गरेको थियो. Comfortable weather मा हामीले free ventilation use गरेर total energy घटाएका थियौं. I'm almost end. म policy को कुरा आउँछु. Policies हामीले चाहिँ के गर्नुपर्छ भने adaptation गर्नुपर्छ, not adoption. There's a big difference between adaptation and adoption. Adoption भने जस्ता त्यस्तै ल्याउने. खैरेले गर्यो, न्युयोर्कमा गर्यो त्यही ल्याउने, it doesn't work. Adaptation भनेको हाम्रो वातावरणमा कसरी ढाल्ने. That's हाम्रो policy should मेरो मान्यता के छ भने हाम्रो policy गभर्नमेन्टले बनाउने policy हामीलाई कोड बनाएर कान निमट्ने होइन. Policy should be aimed at scientific research for adaptation of EV measures suitable for average weather in different parts of the country, primarily through university. त्यो मैले underline गरेको कारण किन छ भने जति quality research universitiesहरुमा हुन्छ अहिले हाम्रो सब दुईटै अब अरु युनिभर्सिटी पनि होला दुईटा मैले क्लोजली एसोसिएटेड भएको त्रिभुवन युनिभर्सिटी म त्यहाँ हुर्केँ काठमाडौँ युनिभर्सिटी त्यहाँ म पनि माइती र घर जस्तै हो काठमाडौँ युनिभर्सिटी त्रिभुवन युनिभर्सिटी So they are, both of the universities are capable universities. They can do quality research. अर्को बारे पनि हल्लान मलाई थाहा छैन ओके PhD प्रोग्राम्सहरु छ म संसारमा रिसर्च तीन किसिमको संस्थाले गर्छ एउटा युनिभर्सिटीले गर्छ एउटा कम्पनीले गर्छ डाइकिनले गर्छ टोयोटाले डाइकिनले गर्छ मित्सुबिसीले गर्छ किनभने त्यो गरेन भने कम्पिटिटरले त्यो भन्दा इफिसिएन्ट प्रोडक्ट मार्केटमा ल्याइदिन्छ उसको त्यो जहाजै डुब्छ So companies do it, universities do it, अर्कोले गर्छ रिसर्च आर्मीले गर्छ संसारमा क्याटेगोराइज गर्दै 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 गयो भने हामीले रिसर्च गर्ने चीज तीनटाले गर्छ यो युएस मा त इभन आर्मीको रिसर्च पनि युनिभर्सिटीहरुलाई जिम्मा दिइरा हुन्छ त्यसैले हामी नेपाललाई युनिभर्सिटीलाई रिसर्च पत्याउने चलन छैन that should be done that's our policy focus र provide incentive for design and construction of energy efficient building to both designers like architects and HVC designers as well as the owners and developers. Agi सरले देखाउनुभयो केही नक्सा पासको पैसाहरु त छुट त भइसकेको रहेछ maybe our policy should go in that direction भन्ने चाहिँ मेरो मान्यता हो. Develop benchmark energy use for different types of buildings such as residential public buildings. अब यो benchmark गर्न चाहिँ यो टेबल टपमा बसेर ल्यापटपमा बसेर हुने हैन इन्स्ट्रुमेन्टेसन चलाउनु पर्छ गएर साइटमै गएर गर्नु पर्छ लट्स अफ वर्क त्यसमा चाहिँ गभर्नमेन्टले इन्भेस्ट गर्नु पर्यो पोलिसी त्यता जानु पर्यो भन्ने चाहिँ मेरो चाहिँ आग्रह हो र आवर पोलिसी शुड बी फर एडप्सन नट एडप्सन एन्ड अरु चीज चाहिँ अवेयरनेस क्रिएट गर्नु पर्यो स्टडी एन्ड डेभलप नर्म्स फर मिनिमम एन्ड म्याक्सिमम थर्मोस्टेट सेटिङ government buildings give unambiguous tax incentive मैले चाहिँ 5 मेगावाट को सोलर राखे भने तिमीले भन्दिनु पर्यो सरकारले विदाउट फ्याङ्की फ्याङ्की तिमीले चाहिँ यति पैसा मात्रै तिरे पुग्छ 1 मेगावाट राख्यो भने यति पैसा तिरे सो दैट म त्यहाँ अफिसमा गएर झ्यान्झलात गर्न दिमाग 25 दिन लगाएर दिमाग गर्न नपर्यो अनएम्बिगुअस त्यो भयो भने मान्छे इन्करेज हुन्छ अब त्यो गएर त्यहाँ गएर चाहिँ 3 महिना धाएर चाहिँ 2 किलोवाट को डिस्काउन्ट पाउँछ भने आजकल कोही पनि गर्दैन त्यसैले कि डेभलप बेसलाइन एनर्जी युज अब मैले यो छुने छु नि मिनिमम एन्ड म्याक्सिमम थर्मोस्टेट सेटिङ को चाहिँ म तपाईलाई एउटा स्लाइड देखाउँछु दिस इज जुलाई 11 1979 को न्यूयोर्क टाइम्स हो कार्टर भन्नाले त्यो बेला प्रेसिडेन्ट युएस प्रेसिडेन्ट कार्टर थियो जिमी कार्टर Carter orders 78-degree cooling limit for public building in this summer. Well, के भन्यो भने फेडरल बिल्डिङहरुमा 78 भनेको 25.5 25.5 डिग्री भन्दा टेम्परेचर कुल गर्न पाइदैन यो कुन बेलामा भनेको भने जुन बेलामा अरब वार सुरु भयो अनि उनीहरुले पेट्रोल रोकिदिए अनि एनर्जी क्रन्च आयो युएसमा एनर्जी सेभ गर्नलाई चाहिँ कार्टरले यो अर्डर ल्याएको दिस इज अ भेरी फेमस अर्डर सो 25.5 डिग्री भन्दा फेडरल बिल्डिङमा एनर्जी घटाउन पाइदैन हामी कहाँ के हुन्छ जाने बित्तिकै थर्मोस्टेट मिनिमम 18 या 16 झ्यालढोका खुल्लै चलिरहन्छ तपाई बिल्डिङ थर्मोस्टेट बिल्डिङलाई कति इन्सुलेसन दिनुहुन्छ सो दिज आर यो सबै समष्टि रूपमा नहेरिकन डिजाइनरले आर्किटेक्टले मात्रै या एचबीसी ले मात्रै युजरले कोअपरेट गरेन भने बिल्डिङ क्यान नट बी एनर्जी एफिसिएन्ट भन्न खोजेको Our last मेरो contemplations, Nepalese weather patterns are unique. It is just not possible to adopt such technical matters like building energy efficiency system from another country. We cannot adopt late. We cannot hope to next 5 years or 6 years. We cannot even मेरो विचारमा चाहिँ professionally जाने हो भने we cannot think of making Nepal Griha or Nepal Lead. It's too early, too immature because we didn't have data. मेरो मान्यता के छ भने पोलिसी भने कस्तो तपाईको बगैँचामा गुलाब छ जुई छ जाई छ विभिन्न फूल छ भने पोलिसी भने त्यो सबै फूललाई एउटै धागोमा उनेर चाहिँ राम्रो माला बनाउन चाहिँ कोड चाहिन्छ पोलिसी चाहिन्छ जब फूलै छैन भने हाइपोथेटिकल पोलिसी बनाएर के काम सो मेरो आग्रह र म चाहिँ सबै सेमिनारमा भन्छु यो रिसर्चलाई ओरिएन्टिङ केही वर्षसम्म हामी चाहिँ यो अमेरिकन कोड जस्तो लीड्स जस्तो त्यो फ्यान्सी कुरा नगरौँ हाम्रो आफ्नो सिस्टम डेभलप गरौँ जब तपाईको गार्डनमा 20 किसिमको फूल फुल्छ भने अनि कस्तो माला उड्ने त जस्तो पोलिसी बनाए नि हुन्छ जस्तो कोड बनाए नि थ्यांक यू मेरो यति भन्नु छ जी ब्याक टु यू
Thank you so much, Sir Rabindra sir, for a wonderful presentation. We have, yes, well, commenting and gaining the knowledge from your presentation. Yes, of course, we have to think several factors for maintaining the energy efficiency in the building, not only the architectural aspect, but also the mechanical aspect, such as the energy efficiency of the equipment that we use and the latest technology that we adopt. Definitely, uh, definitely play a roles to maintain the energy efficiency. Well, you all you come up with the setting of the benchmark for the energy efficiency in the Nepal, and the role we have to do voluntarily, not only seek to the policy from the government, but also acting from our side, so that we can call up the government for setting up the policy and the guideline for maintaining the energy efficiency. And of course, the role of energy in the consumption in the building for saving the delivered energy in our houses and the building, so that even a little saving of the energy that we consume from the national grid of the electricity of Nepal can maintain and save the national energy consumption for in the long term. And of course, your suggestion for incentive awareness and the research for setting up the benchmark for the building is highly feasible, and we are surely that we as a student from energy efficient building and other people will sure come up with your guidelines and suggestion, and we'll do our best for setting up this. With all this, now I'd like to call upon our final speaker, Architect Ujjwal Man Shakya sir, for dropping his valuable remarks on establishing and practicing the culture of energy efficient building in Nepal. With a short bio of Architect Ujjwal Man Shakya sir, he is a well-known figure in practicing the green building design in Nepal. Almost he have spent his 2 decades in implementing the green building design principle in Tarai, hilly, and mountainous region of Nepal. Well, he has been leading the Innovative Creators Private Limited as a managing director since 1987. Some of his remarkable green building design are office building of Buttle Power Company, which is located at New Baneshwar, Dala Resort at Farping, Taiko Eco Resort Hotel at Nagarkot, and residence of Mrs. Sushila Shakya at Maharajganj. Besides that, yeah, architect Shakya has his innovative design approach of using solar air heating panel for heating building and solar chimney for cooling a building, apart from the earth air tunnel for heating and cooling of a building. And currently, he is involved in Nepal community reconstruction program by USAID, and as a team leader and as a project architect to several iconic projects. With all this, now I request architect Ujjwal Man Shakya sir to drop his remarks. Sir, the floor is yours.
Thank you, Chitis. I think without losing any time, I would like to start my presentation. Okay. Can you see my presentation?
Yes, sir, we're viewing you. Yeah.
Okay. First of all, I would like to thank the Department of Mechanical Engineering graduate student on energy efficient building design team. And as I always used to say that energy efficient building design or green building design is teamwork of architects and mechanical engineers. So to achieve a successful project, we have to work together. And today's topic is very much interesting, and that is approach towards sustainability, design and practice of EEB in Nepal. Not only design, but practice of energy efficient building in Nepal. That's very much important, because in Nepal, we have a lot of things to do in this sector. You see, Nepal is a poor country, and we are even poorer in context of energy efficient building designs. We have to go a long way ahead. So having these topics, practice of EEB in Nepal, it's my great pleasure to share my designs, which I always try to design in context of Nepal. Even when I was student, I studied in Belarus, Russia, but I always try to design buildings in Nepalese context. So here I would like to recall what Professor Sushil Bajracharya mentioned, that we lack awareness and we lack lack of data, and we don't have proper technology, and we have no human resource for coping with this problem. And I am very much impressed with Professor Bhattarai that we have to go for adaptation, not adoption. So this is what I always think, and I'm very much hopeful that the awareness is getting on and we are moving on, and one day we'll also stand tall in scenario of global scenario of green building design or efficient building design. So let me start with my content of presentation. First, I will quickly throw introduction to energy efficient building and EEB design in Nepalese context. That's very much important. And I will share with my energy efficient building projects. And I would like to discuss about hot takes on Nepalese EEB discourse. And lastly, conclusion. So I don't want to spend time on definition of energy efficient building design, but here I would like to draw attention these few words: consumption, maximizing efficiency in use of resources. Yeah, this is very important. Maximizing efficiency in use of resources, that we have to be focused on. And if we talk about green building design or energy efficient building design, we think about mostly during operation and maintenance costs, during lifespan of a building. But if we try to design a building to be energy efficient, we have to start thinking from pre-construction. It's also very important. It is related to embodied energy, as we all know, and the energy uses for transportation or carbon emission during transportation. Now, during construction also, we have to think about energy efficiency, and that's related to technologies and appliances we use during construction. Technologies means we can use prefabricated column beams and wall panel and so many things. And if we think about appliances, we have to use energy efficient appliances during construction also. Like if we simply use some water pump, then we can use water pump with variable frequency drive, that we don't have to spend much energy in pumping water. Yeah. And during lifespan of building is the main thing, main phase we all working and we are all worried about. And this is the 90% of the job we have to do. And now, after saying pre-construction, during construction, and during lifespan of building, and if we talk about energy efficiency of a building design, and we have to think about the demolition of phase also, because during demolition also we have to think that the demolition process should be energy efficient. So now I would like to highlight about sustainable energy. Here, renewable energy and energy efficient technology, they are two different concepts with same objective. It's two sides of a coin, and that is now we call sustainability. And sustainability is more nowadays popular. So far, we are talking about the energy efficiency. So here I would like to mention that in building design scenario, in-site renewable energy should be in category of energy efficient building design. And actually, the energy efficient design and renewable energy, they are synergies. Together, both we can make more proper use of energy. Now, I would like to share my design approach in Nepalese context regarding energy efficient building design. First of all, the energy efficient building design should be climate responsive, local climate responsive, like for Bhattarai, hill and mountain, we have to design accordingly the site condition. For example, for Bhattarai, we may need more height and more cross ventilation. In hill and mountain, we don't need much height, and solar gain, all these things are related. And use of simple technology, this is very important. And if we use complicated technology, we may face, and we are sometimes facing problem in technology, because we know that in Nepal, we are not so developed. And due to this reason, we have to try to stick on technology which is available in Nepal. And use of local construction material, so far possible, we have to use local construction material like in mountain, Bhattarai and hill. And design, we have to design as per local level skill. If local people cannot construct, why we have to design something like that? And more important factor is use of in-site renewable energy. We have to maximum use in-site renewable energy. Now, innovative creators always try to achieve good energy efficient building design from last 2 decades, when even the green building design concept or LEED concept was not in practice. So there are few selected example I would like to share in this presentation. So first of all, the Bhattarai Power Company project. So in this project, we have designed this project to be compliance with LEED certification, and we design all the components as per LEED checklist. But unfortunately, as Prof.Rabindra N told, that in Nepal, we are not capable of achieving that certification. And the main concept in this building is use of solar energy for heating of space. The heating of water and use of photovoltaic cell for producing electricity is very common in Nepal. But I thought, and I always like to implement this practice, that in Kathmandu, we really suffer for 3 or 4 months. And we have a lot of energy, whole day solar energy during winter. Why not to use this solar energy, which is free? So with this design approach, I have designed Bhattarai Power Company building. So in this building, as you can see, the 60 numbers of solar air heating collector of which produces 264 kilowatt hour per day, and photovoltaic cell of 4 kilowatt, and 5 number of outer tunnel, and one number of wind turbine 3 kilowatt. And we have used world-class energy efficient practices. This building, all the windows are double glazed, and we have used heat insulation in roof and walls, and energy lighting system, not only lead light, but also with sensor. When there is no occupants, the light will automatically turn off. This is also very important. And energy efficient HVAC system, that's ARV type HVAC system. Do you hearing me properly?
Yes, sir.
Okay.
Yes, sir.
Yes, yes, we hear you, Ujjwal sir. You're very good. Yeah, please go ahead.
Okay. Now this project is combination of hot-air tunnel and solar air heating system. And hot-air tunnel, I am inspired by Professor Bhattarai. When I was just graduated, I attended one seminar where he delivered his presentation regarding hot-air tunnel. And here in this project, I felt that in Kathmandu, we have a lot of humidity. Professor Bhattarai also showed the diagram, graph that in Kathmandu, we have always more than 60%, about 80–90% humidity. That's why during winter, we feel cold differently. And I felt that merely having cold air from hot-air tunnel is not sufficient for heating of the office spaces. So I count the air from EAT as preheated air and supply it to solar air heating panels, and then it will blown to the office room and it will come back like this and recycle, reused. And this is the plan of the power company. So this is where the building stands. It is oriented to south. That's very important. And this is the intake building. This is the intake building, and this is these are the hot-air tunnels. And this is fresh intake, and we have dehumidifier placed over here. And it's very important because as I just mentioned, in Kathmandu we have a lot of humidity, and comfort is very much related to humidity content in the air. So we have decided to have humidifier at source. Usually, most designers place humidifier at the in, where there is blower or mechanical room, yeah. But since we have a lot of humidity and the air get cold when it travel to inside outer tunnel, and it will produce a lot of condensation, and a lot of condensed water will be in EAT, and that way may result into development of mold and fungus, which is not good for health. So you can see all those green building measures in this project. And since we are talking about energy efficiency in building design, now I would like to mention the renewable part of this project. So this is how we have managed earth heating, solar heating panels. And these are photovoltaic panels at top. And now we can see that these are return ducts from the office below, and this is supply plenum inside, and Belmont connection to solar air heating panels. And as I mentioned, there is one small wind turbine. So this is the utility room as a 3D of all the connection of ducts inside, and these are the inside view of the atrium after construction. And as you can see, these are the dampers, and here we can see properly, but here is the blower. So this is your supply schematic diagram during summer. Now we can see in this diagram that from outer tunnel, we block the damper and it will travel to the rooms directly. Air intake, fresh air, it will get cooled. Oops. It will get cool and it will be supplied to room by supply grid, and these are the return. So this is how it will work during summer. And this system works, we have set it, the building management system, BMS system, for summertime, and this is for winter, and in between winter and summer, for autumn and springtime also, we have a lot of arrangement in the supply and recycle or return or taking away the air, all those system in this HVAC system. So in summertime, the damper over here will be closed, and the EAT preheated EAT air will be traveled to the solar air heating collector, and it will supply it to the rooms. And I would like to draw attention to a heat pump HU. This we have provided because in Kathmandu sometimes we don't have solar sunshine for 4 or 5 days. At that time, this heat pump HU will supply hot air to office below. So as I told earlier, this system is controlled by building management system, which is assemble manufacture in Nepal. The supplier is real-time solution, and we work hard on this project for achieving this building management system made in Nepal. And so you can see that the outer temperature is 15, return air temperature 20, outdoor temperature 13. Yeah, but outdoor humidity is 51%, supply temperature 29, solar out temperature 32. Yeah, carbon dioxide is 1.05 ppm, and setting is for winter. So with setting, we can open, close dampers and monitor the carbon dioxide and temperature and humidity, and accordingly the whole system will work. So this is how we manage supply grill and return grill over here, and duct alignment in vertical shaft, and horizontally the ducts are aligned like this. So this is graph of which we recorded in BMS system, and this is the ambient temperature, and this is room supply, and we have solar collector temperature like this. So we are having very good hot air supply system during winter. So here I would like to share a simple thing which is very important. Orientation of the building is very important from energy efficient building design point of view also. The building should be oriented towards south. It's very simple and very important. And I try to block unwanted western solar rays during summer. As we all know that during summer, harsh sunlight from west always overheat the building. So I block western unwanted sun rays by placing staircase over here and by placing restroom over here. So a lot of overheating is blocked by placement of the staircase and toilet. So we have other heat island effect prevention by providing green roof, and we have used water urinal, and this is the root zone treatment with anaerobic filter system for recycling water. So this is another project which is similar to BPC, but only development we had done is for solar panel, we need about 40 degrees, and for photovoltaic cell, we need only 30 degrees. So to improve the efficiency, we have developed roof to house different type of solar panel to increase efficiency. Now, this is another project built at Maharajan Chapal Karkhana. This is a residence building. In this project also, all the renewable energy parts are similar to BPC building. Now, I would like to share some line diagram of this project. And actually, this project comprises two parts of building. I have specially done this two part zigzag to have maximum solar gain in south elevation, south side, and the site is along to north south, and it was difficult to achieve orientation of the building. So usually from architect point of view, I don't do this type of thing, but we have to compromise from some point of view. So this is one part, and this is another part. However, I use these two same for one for during winter and for summer and winter. Now in summer, from EAT, it will directly go from IDU to rooms, and it recycles. And in this building, we have more simplified building management system. And during winter, the air will travel to solar air collector, then it go through IDU to zone 1, and it will come recycle, or it will pumped out. It depends upon the temperature of the room and temperature outside. Now, this is my project, Jala Resort at Pharping, which we completed a couple of years ago. And in this project also, everything is like same at BPC, but except there is no EAT. There double glaze, cavity wall, and rainwater harvesting and recycling, everything is there, but only there is no EAT, because we felt that the atmosphere over here is so cool that we don't need EAT in this building. So as since the audience are more from mechanical engineering student and pass out from mechanical engineering course, I like to share these diagrams which we developed even with sizing of those ducts, so that it's easy for us to work. And here also the system is same. This is during winter. The air, fresh air will travel to solar panel and supplied to different stack in ducts. Now here I would like to draw attention that we have two blowers over here. Why two blowers? Because even these blowers runs in backup electricity. When we design and started implementing, there is tremendous load shedding, and in order to cope with that problem, we have designed this blower that can be run by backup electricity supply system. And in this project, we have worked with Professor Bhattarai, and we achieve very good result in achieving energy efficient renewable energy system in this project. So it's all our teamwork with Professor Bhattarai. So this is a summer scheme. Now I would like to show you the BMS control panel. It's very much simple control panel, BMS. And this is BMS display panel. Now, I would like to share another project. This is residence cum office building. And actually, this is my own building and office. Upper floor, I live in upper floor, and this is our office. So in this project, the solar air heating panel, it is designed with a reverse system. Yeah. Usually hot air go up and supply to below, but in this system we have reverse direction so that we can use this solar panel during summer for extracting unwanted heat from the office. Now the heated air will travel to the supply grill, which is over here. I've shown it over here, and it will travel to below, and here is the return grill. And the air will travel like this. And with the help of these panels, the office is heated with solar energy. And during summer, as I told earlier, once the air is heated, it will move up and it will create draft, forced draft, that we can have hot air pump out without spending any energy, not renewable, not even electricity. So it's just by natural heat, by nature it will go out. So this is water heater, and this is where our air heating panel are mounted. So here I would like to share this slide. We have installed 4 sensor, heat and humidity sensor. Since in our country we don't have data, it's very difficult to work, and we thought to have our own data, at least some data in our own office and in my own building. So I have placed 4 sensor, and it's like one obviously outdoor sensor, yeah, and one is office area where we have single glaze and 9-inch single brick wall, and bedroom where is double glaze and cavity wall, and solar space where we generate heat for supplying hot air to bedrooms. So it is 30 January at 21.35 is at night, and we can see that temperature outside is 12.9, in office is 17.5, and bedroom is 21.5, and solar space 20. So it's pretty good. You see, outdoor temperature 12.9 and indoor temperature is at bedroom is 21.5. It's because of I have used the solar space to heat bedroom, and I have used double glazed window, and I have used cavity wall for maintaining the heat. So this is how it works. And next morning at 10 o'clock, we can see the outdoor temperature is 14 and bedroom temperature is 20. And solar space started to get heated 22.4, yeah, and office temperature 14. And now we can see that even at morning, 10 o'clock, we are having comfortable temperature. And I don't have to switch on, use heater, any type of heater in my bedroom. And this is at 11 o'clock, outdoor temperature 15, and at solar space is already 25. And at mid-peak time, at around 1 o'clock, we can even have 40 degrees in solar space. So this is our next project, Tire Eco Resort. In this project also, we are working with Professor Bhattarai to achieve energy efficient building and use of solar energy for different purposes. And we have 34 number solar water heating panels and photovoltaic cell for 10 kilowatt, and 20 number solar air heating collector, which I mentioned over here. Now, these are the features of energy efficiency, and now how it looks from outside. And after taking out the solar panel, these are the connections of the solar air heating panels, and inside we have all these ducts and blowers over there. And this is meeting room, conference room, and we are using solar air heating panel to heat this conference room, because mostly the conference will be conducted during daytime. Now we have written here over here, it will pass through the solar air collector, and it will be passed through the blower, and it will supply. And here it's very important to mention that supply here is at this height. With close consultation with Professor Bhattarai, we have decided this height, and he suggested to have this type of air circulation. And now we have these motorized dampers and non-motorized dampers over here, and motorized dampers over here. And during winter, this one of this damper will be open and another is closed. And this is very simple system. We don't need any building management control. And this is during summertime. Since Nagarkot is a very cool place, we don't need outlet tunnel for this project. And we have used solar energy to extract hot air from the conference hall. Like the heated air will go out, and it will draft air from the conference hall, and the fresh air will supply from here. And this is all manual dampers. Now, I would like to show the passive solar design of my project. This is Department of Electricity at Bajracharya. In this project, I have used solar space to supply hot air to few rooms over here during winter. And during summer, how it works, I'm showing this diagram with arrows. And the plan of this building is in mandala shape with at center, there is atrium open to the sky. And so it acts like a duct for air circulation. And once the upper part of air is heated during summertime, it will create draft. And once the window is open at one side, it will travel through this central shaft, and it will go out. So it creates a pleasant breathing inside the wall of this building. So this is another project where I use solar energy for not heating, cooling of the building. Since the project is at Hetona, where it's very hot, I have designed these solar chimneys at rooftop. The idea is when early in the morning, when first sunrise comes, it will hit on the black painted chimneys, and air will hit it, and it will travel up. And when air will travel up, there will creation of draft inside the rooms. So I have provided two cooling space, cooling zone, baranda, deep baranda, and it doesn't need any energy. It's a natural draft system that I created. So I'm also pretty much impressed by vernacular architecture of those hot climate zones. And this is how I designed this building. And another concept is the defining of this height of the chimney is based upon the draft air flow that will occur during night time. And we see at mid-morning, 4 o'clock, the air is pretty cool at any hot climate zone, like in Hetona or Nepalganj, wherever. And the air will be circulated and go out. And during this process, all the furniture, walls, and ceiling will be cool. This is called thermal mass concept. And the office room will be pretty much cooler. And when staff will come at 10 o'clock, they will definitely feel more comfortable than other government offices nearby. So the main constraint of this building is low body building, and since they don't have Darbandi of engineer or overseer to operate this system, so I have designed this project so that office boy can easily operate this system. What they have to do is open this window, horizontal window, during summertime, close during winter time. So this is how the airflow in plan, and these are the position of these ducts. And this is cooling zone, and we are to travel inside by natural cooling process. And this is where the deep veranda, and inside I have provided louvers up and below, and this is partition wall with glass block which maximum utilize the daylight. And inside office, every nook and corner of this office is lighted by daylight. And this is my another project, is pyramid house, and this is one of the early building in Nepal having double glazed window. This building is constructed about more than 20 years ago. Now, double glazed cavity wall, central heating and cooling system. And this is the supply grill, and this is return grill. Here is also supply grill, and this is a supply grill. And in this system, I have used solar water heating panels to heat water, preheat water. And as we all know that solar panel can heat water up to 60 degrees. And for heating the rooms, we need to supply 70 degrees. So we have to increase temperature by only 10 degrees. So these are the boilers, kerosene boiler, and these are the hot water storage tank and balancing tank. And the hot water is supplied to all the rooms. And the hot water is also used for bathroom and kitchen. And for transferring heat, we have used fan coil in each room. So now I would like to share my opinion regarding energy efficient building in Nepal. We have to take pride in traditional architecture being energy efficient. Of course, we are proud that our traditional architecture are very much energy efficient. But merely saying that and it is not enough. We have to add modern technology to suit contemporary requirement. What I say is, if we only keep on saying that our traditional building are energy efficient, it's something like मेरो बाउले घिउ खाएको थियो मेरो हातसुङ भने जस्तै हुन्छ थियो किनभने हाम्रो पुस्ताहरूले त गर्यो केही गरेर गए तर हामीले अझ राम्रो गर्नु छ. That's my thinking. And another is passive heating. Passive is good, yeah, and we have to think that there is thin line between passive and active technology. If we provide small motor or small pump, it becomes active. So there is immense opportunity that we can take advantage of active technology also, and we have to keep on using passive depending upon the site condition and budget of the building only. Otherwise, we have to think about active technology. Now, rating system, I totally agree with Professor Bhattarai that we don't need all those codes and rules and regulation to that extent at this stage of time. You see, we don't have green building and we don't very less number of energy building. So there is no use of rating system. And uh, instead of that, I strongly feel that we need research department to collect necessary data and do R&D a lot, depending upon, as per climatic condition of Nepal, that means mountain, hill, and tarai, we have to produce a lot of data and we have to do a lot of research. And we are not having anything. The day before yesterday, our Kishore Thapa and another colleagues told that government is doing nothing up to now. And there is, in near future, we don't see anything that there will happen something. Now, lastly, I would like to express my view regarding pandemic resilient design. Now, we all know that HVAC system design will not be same again like before. It will be changed after post-COVID scenario. Now, we all know that to make a building pandemic resilient, we need a lot of fresh air, which will result into a lot of energy demand. And it may demand of all your system so that fresh air will be supplied all the time inside the building. But that is very expensive. And here is the solution. The sustainable energy system is the solution. With this solution, we can easily, with minimum cost, have a lot of fresh air, controlled fresh air supply inside a building. And in this sector also, we will have to work a lot because we have to cope with this pandemic problem. So in conclusion, I would like to say that we have problem with global warming and electricity develop, even in hydroelectricity is cleaner, but still we have some adverse impact in modern nature. And we have to think that energy is precious, and energy we save is energy we produce. That we have to think. If we keep on producing indefinite energy and spending it, it's not wise. We have to preserve energy, we have to save it. It's like money on is not only money on. Money saved is money on. So energy saved is what we energy produce. That we have to be very much attentive. And there are a lot of immense opportunities in Nepal, and we together with mechanical engineers, architects, and engineers can have achieved a lot of things. And of course, we are just crawling towards achieving that goal. Therefore, let's save energy for benefit of oneself and nation, and let us take pride on being energy efficient. This is not the end. Thank you. We have to work hard. Thank you for this opportunity to share with all the audience. Thank you.
Thank you, Ujjwal sir, for your wonderful presentation. Yes, indeed, energy we save is the energy we produce. Ujjwal sir has really taken up on tour on the current practices of energy efficient building in Nepal, and we are really glad to view the work of BPC building, which is the LEED certificate, along with the integration of renewable energy and the adaptation of passive materials for maintaining the energy efficient building, as well as the Office of Security Trading Building, Chappal Karkhana, Dala Resort, and many more. Beside this, the initiation to collect the data of temperature and humidity for knowing the changes in the environment, to gather the data for further use is really appreciable work. And then yes, the pyramid house is really amazing to see us that already building with a central heating system and cavity wall with passive features and integration of active features is really amazing for us to know the how to design the energy efficient building in current practices and how to take up this trend in the future use. Mm, yes, with all this, I would again like to thank you, Ujjwal sir. Now, without any delay, I would like to see the question answer box for is there any questions? Well, in the chat box, I think there's no question anymore. So without any delay, I would like to invite our, yes.
Chitiz, I think its time is also getting late, so you can directly go to Daniel sir for his remarks and others. Yeah.
Yes, sir. I would like to now invite the Daniel sir, our associate professor, head of Department of Mechanical Engineering, for dropping his remarks. Daniel sir, are you there? Daniel sir?
Yes, I am. I'm here.
Yes, sir.
Thank you. First of all, in the behalf of Department of Mechanical Engineering, I'd like to thank you all our presenter, Rabindra sir, Sushil sir, Professor Sushil Bajracharya sir, Ar.Ujjwal Man Shakya sir, and entire team, because with this presentation, we have learned a lot of things.
Ujjwal sir, would you mind stop sharing your screen, please? Ujjwal sir, screen out. I did not see it.
I'm trying, yeah.
Yeah, thank you, sir.
Oh, okay. Now I think I will be more visible to you all because of the light problem. Maybe not so clear here because of the sound problem here. And as we know that we have started this energy efficient building in 2018 as a course. Now again in 2020 intake also, we are introducing this course from our department, this energy efficient building design. And I think this type of workshop, webinar will help the student as well as our pass out student, as well as new intake to know about the exact what is the use of this energy efficient building course in context of Nepal. So in that regards, I like to thank the team that has organized this webinar for this energy efficient building. So thank you very much. Thank you, presenter. Thank you all the participants. Thank you all the organizer, and hope to see you again. Tomorrow is our day. Also tomorrow also we'll be having this program. In the next year also we'll be doing this type of program. So I like to thank you all and see you once again tomorrow in this webinar. And thank you very much. Thank you, Sushil. Up to you now.
Thank you, Daniel sir.
Mostly to all you
for your closing remarks. Yes, I would like to now thank you all our speakers for their wonderful speech and for wonderful insight, providing their knowledge and expertise on energy efficient building for us, especially graduates and other followers who are setting up in this field for doing something in the building area. So I, on behalf of graduate student in energy efficient building design in Kathmandu University, would like to thank you all for your presence and our participants too. Well, I want to make an announcement that tomorrow we are having our third session on integration of energy efficient building with retrofitting features by our Professor Dr. Wolfgang Stretcher from Austria in about 11 a.m. tomorrow. So now I'd like to wrap up the session with a huge applause from our side, sir. Thank you so much, sir. We'll see you next time.
Okay, thank you.
Okay, thank you.
Thank you. Namaste, sir. Namaste, sir.
Thank you. Thank you. And make available this recorded version to all of us again, and you'll have that. Okay?
Yes, sir. I'll make it available.
Yes. Thank you very much.
Once again, thank you so much, sir.
Thank you, sir.
Yeah, thank you. I'm leaving. Okay, I'll leave.
Okay, thank you. Stay safe. It is.